Next up is our next project here is a Pioneer TX 7500, which is a perfect match for the SA 7500 we just restored here a little while ago. And I picked this one up, and it looks to be in relatively good condition. A couple little marks on the cabinet, but nothing that we can't take care of. And I've not even plugged it in or tried it yet. I have no idea if it works. But the really good news is I actually have an actual authentic service manual for this, complete with schematics, parts lists, alignment and calibration procedure, the whole 9 yards. So this ought to be a fun project. I like working on tuners. Hopefully we can get this one to perform. The 7500s were known to be, from what I understand, were supposed to be really pretty good tuners. So I'm pretty excited to get this fired up and get it working and back into top shape and see how it performs. So let's connect everything up and see what we get. Okay, we have our high-end tuner hooked up to our very low-end bench amp, and we're going to turn this on and see what kind of thing we get here.
All-wheel drive for just $169 a month. Your volume price leader is Boardman Mitsubishi.
I guess that's good.
Or online at BoardmanMitsubishi.com.
Okay.
History of message from the Centers for Disease Control and Prevention. Out of nowhere,
Well, looks like there's not going to be a whole lot to do to this one. Sounds like it's working pretty well right out of the box. Take over to AM. Not so good with AM. Okay. Getting a little bit of noise on that, but AM might need a little touch up. But everything else sounds pretty good, so alright, let's take it apart, and definitely need to clean the controls. They seem to be a little bit spotty, but this looks like there's not going to be much of a video to this one, so we'll see what we get. Alright, pretty unexciting here. We have the tuning module right here, your capacitor, you got a weighted flywheel, very nice. Your main board, little power supply. Look at that, 4 fuses just for this little tuner. Definitely well built again, typical Pioneer of this era. Doesn't look like anything's ever been done to it, and it doesn't really look like very much is going to need to be done to it. I may change these power capacitors. As far as these ones down here are concerned, if they're not leaking, if everything's working well, I'm not touching them. Definitely going to go through and clean them, clean everything up, check all the little lamps, make sure they're all good. Maybe do a little upgrade to some LEDs, I don't know, we'll see. And wow, that's about it for this one. This one might be a simple one. Now again, you notice we had some problems with the AM, so we're going to have to look into that a little bit. But I'm going to go through and clean some things up and take it a little bit further. Alright, we're back. There has been some work done on here. You can see these were like bayonet type bulbs with the little flat bottoms with the little that you push down in, and you can see somebody has soldered these little grain of wheat bulbs in here. And the way they work is these little contact pins here, right here and here, when they go down in here, you put them in half a turn and they make contact with this little board. So obviously this was kind of an aftermarket sort of thing. So what I'm going to do here is I'm going to try to retrofit this with an LED system. Looks like it's going to be fairly simple, being that really all we got to do is, here's your incoming power, so we got to change that to DC, so we have to put a little DC with a little regulator on it, maybe a little dropping resistor. These couple grain of wheats we may be able to switch out also for some LEDs, but I don't know yet. We'll see. They seem to be working. And see what kind of light we can get going in here. Alright, so I removed the board and I decided to convert this all over to LEDs. And as you can see, I took these little tracks were already on here and not used, so I ended up using them for making a little makeshift bridge rectifier. And I took out the 2 pins for the input wires, put a little smoothing capacitor across there, not that you really need it. And then each LED, I put a 470 ohm dropping resistor. When I did the math, it came out to get me about 15 milliamps at the required voltage for the LEDs. I'm using some warm white LEDs. They look actually pretty nice. Here's our power LED, and when I hook these up, I think it's going to be pretty decent here, trying to do this with one hand. And as you can see, they all light up pretty good. There's our power LED. So, alright, so now all that's left is to get this mounted up in the little frame over here. Sorry about moving around on you. And this is a little mounting frame. It goes in here, goes to the light diffuser, and then I'll tag these little supply wires here onto my other wires here, tuck them away neatly, and we should have some nice looking lights. Okay, let's get the effect, see how it looks. Very nice. I think that'll do just fine. Okay, on to our next part. I have the schematics open here for this TX7500 tuner, and right now I'm looking at the power supply. It's really important that you have a really quiet power supply on these tuners, because of course the more noise you have on your power supply, even if it's a little bit, it can affect the sensitivity of the tuner overall. So one of the things I always look for is to make sure that the diodes for rectification are bypassed with little capacitors, and they did their due diligence. That's already been done for us. I look at the regulation, and they're actually using a linear transistor regulator circuit, which is pretty good. I'm looking at some of these capacitors here. The values, they don't look too bad. Remember, this doesn't draw very much current. We have a separate winding on the transformer that is for nothing but the bulbs. So really, bulbs, incandescent especially, draw current. As you can see, once again, that's all coming from this coil. So really, this winding for the DC supply is really not being asked to carry a whole lot of current. With that in mind, though, modern replacement capacitors, I could probably take this 1000 microfarad and go up a little bit and not hurt the transformer. It's a pretty good sized transformer for such a small capacitor, so I may be able to take that up to maybe a 2200, which sounds, doubling it sounds ridiculous, but remember, this is a pretty decent sized transformer here, and it's rated at 0.5 amp, and I think we might be able to get away with that. I need to do a little more calculating on that. The other thing is, when we come up here with our 25 volt supply, you see that it comes up to this little safety relay circuit, and basically what you have is a 47 microfarad capacitor, and it goes to ground through this coil. So 25 volts goes in, charges the capacitor, capacitor charges, So during charging, relay comes in, and then looks like possibly when capacitor is fully charged, then transistor has to turn on for the current path to get to ground. So that's your safety circuit. So this is capacitor looks to be like it's just going to kind of bypass this for a while, and then once this guy's up and running, as long as we don't have any problems with our safety circuit, this will latch in, this will bias on and keep the relay in. So that's kind of your safety circuit there is what you're looking at. I'm not paying attention here. I'm hoping this stays focused while we're talking. So anyhow, that's what we have. Power supply doesn't look like it's going to need a whole lot done, but I am going to recap it. Anytime you have main power supply for the price of capacitors, it's worth doing. Especially modern caps are so much quieter and better quality now. So I'm going to do those, and then we're going to just kind of step through this. This is going to be my little keeper tuner, so I'm going to just step through every step of it and make sure everything's working perfectly. And so we're starting with the power supply. So I'll get that done, and then we'll come back on and see what we got. Okay, what I've decided to go with for the main filter cap is I'm going to keep the 1000 microfarad 35 volt, but I'm going to go with a Nichicon audio grade 105 degree, if you can see it there, capacitor. And these are very low ESR, very low noise, and very accurate, long-living, good capacitors. So I think this will be a good choice for this power supply. I'll get this put in, and then I'm going to do the rest of them. We have the power supply board recapped, and I added, I removed the ceramic across the line capacitor and replaced it with a safety cap. Although that ceramic one probably would have been alright, but I had it, so I might as well do it. I also put modern diodes in there. Those the old silicon diodes and things sometimes would tend to leak after time. I just didn't want to mess with that down the road, for 10 cents worth of diodes. I did it. So now I have my oscilloscope connected, and we're going to check for ripple. This is a 13 volt power supply, so roughly, and it does not look to be, it is regulated, so it's a regulated 13 volt supply. I'm going to see where we are and check for ripple. So I have it connected to the scope. Let's turn it on, and as you can see, I'm at 2 volts per division, 2, 4, 6, 8, 10, 12, just under 14. I'm just a little bit high, but that's alright. 14 volts, and as you can see, there is no ripple in there at all. And if I went to AC coupling and brought the voltage way down, we might be able to see some ripple somewhere eventually. You can see right there's a wee little bit. Hardly anything at all. So we're good. Alright, so off to the next thing. Alright, after double checking, this little Zener diode, which is supposed to be 14 volts, had crept up to around 15, which was causing this to go a little bit high, which was why we were getting closer to 14 volts on our output. I replaced that, and now we're right at about 13.3, 13.4 volts on our 13 volt power supply. So that's perfect. And looking at the watt meter, we're only drawing about 6.5 watts for the whole tuner, which sounds good. And I think we're ready to move on and start checking to see how the tuner works. I have everything hooked up here to do a little pre-alignment test just to see where our alignments are. And one of the things I want to talk about is basically the bandwidth of FM and how it works, and how how the signal works as you change frequency. So right now what I have is I have my signal generator set up for 96 megahertz, and I'm running at 99% modulation, so full modulation, and I'm feeding it with the 1 kilohertz modulation wave, okay, on FM. So basically what I want to do is I'm looking at the output of the output terminals of the tuner, and I want to watch my amplitude to see as I increase frequency if my amplitude stays the same, and it won't, because that's how FM tuners work. The bandwidth of the tuner is just limited. So I'm at 1 kilohertz, and as I jump, I'm going to go in 1 kilohertz steps. So 2 kilohertz, and you can see it already dropped. 3, it dropped. 4, 5, 6, 7, 8, 9, 10. And sooner or later, at about 17 kilohertz, you have almost no signal. And this is normal, but what we're going to look at is to see if we can adjust that to get our optimal bandwidth out of this. Remember, whether you have a narrow or wideband tuner is going to depend on how it performs at upper and lower frequency spectrum. So I just wanted to get a baseline on this, and what I'm going to do now is just kind of follow through the alignment and see if we can get it a little bit better performance. We may not be able to. This may be dead on with alignment. We won't know till we try. But I traced this all the way back to the discriminator circuit, and this attenuation goes all the way through, clear back to the front end of the radio. So I know it has nothing to do with the audio section or bad capacitors or anything like that. Pretty sure it's not a capacitor. It's probably just the limitations of the design, and it might be some alignment. So let's go and see if we can figure out the alignment procedure here and see if we can make it any better. Okay, for starters here, first thing we want to do is we want to connect our signal generator, and they want 90 megahertz. I have it at 96. There's some stations around 90 that might interfere. And they want us to go through a 300 ohm dummy antenna, which we have. We want to connect to the output of the stereo, and I'm going into an oscilloscope. I'm not using a distortion meter. I'm actually visually looking at the distortion, and I tuned it back and forth. And if you listen to this, as I adjust, you can actually watch when I get it centered on the channel. See how it's crushing down when I go to either side? So the idea is to get it as symmetrical as possible using the tuning dial. Okay? So that takes care of that right there. Now, I'll turn this down. Okay, and they want negative 100 dB. When they say 100 dB, they mean negative 100 dBm. Okay, so now they want you to adjust T1 lower core so that the tuning meter points to the center, and as if you could see, the meter is off center slightly. So let's T1, and T1, if we look at it from this angle, it's going to be this one right here, and they want us to use the lower core, so we have to get our adjuster that'll get down into the lower core. If I can pop down through there, I'm not sure, without moving it. Okay, let's see if we can move this. This one's a little bit frozen, so we're going to have to see if we can loosen it up here. I'm going to do that off camera. It's too hard with one hand. Okay, we got that one adjusted. We're centered, and our noise peaks on the signal are centered. So we turn that annoying sound down, and go to our next instruction. So next, they want us to set the FM signal generator output to 8 to 10 dB and adjust local oscillator, LR and LA to maximize audio frequency output level. Okay, so I'm going to go get that set up and then I'll be back. Okay, I peaked out LO, LR, and LA at the 96, and now I'm going to take this and I'm going to adjust the 106, which is pretty close already, and I don't think it's out at all. I think it's right in, but we're going to adjust TCO, TCR, and TCA. So here we go. So I'll start out with TCO. I'm going to try to do this one-handed, which may not be real easy. Let's see what happens. Okay. TCO. See, that jumped right out. Get a better adjuster. Okay, looks pretty good and pretty symmetrical. All right, now let's look at TCR and TCA, which once again, I don't think these are going to be out at all. Yep, that one's peaked. And TCA is the last one, and as you can see, that was right in there. So those are all good. Okay, let's turn off the noise, and our next instruction is to repeat the steps till the output is maximized. So we go through that, and then FM signal readings to 90, adjust the IF, audio frequency output level, when signal generator is 8 to 10 dB. Okay, so we're going to go back. Let's try 90 this time. Frequency 90 megahertz. And we're going to tune this down to 90. Turn up our volume. And as you can hear, I have an adjacent station, and you can see it right there interfering with me. As soon as I'm centered, I can go up a little bit. There. That overcomes the adjacent station, but once again, that doesn't allow us to see the this distortion, but I don't think that matters so much for the IF. IF, we're just looking for a peak. So let's take IF, and I'm gonna, there, and we're going to peak the IF, which is right down here, and I can't even see the slug. Hopefully it's this type. Yep, it is. Alright, let's adjust it and see what we get. Okay, IF is not doing anything, so we really need to get, okay, there we go. Okay, so there's your little peak right there. Barely moving, but that's it. So it was on. That one was on. Okay. Once again, we're going to do tuning. and we want to set that to center. And our tuning meter is pretty well centered. We don't have to move it too much. I'll try to reset it again, but I think it's pretty darn good right how it is. Let's see what we can do here. Well, too much. Right about like that. Okay. And there we go. And you can see as I go on either side of the channel, it folds in the one end right there. So that's centered. Our meter should be pretty well centered. It's still off a wee little bit. So let's take okay. So I got that centered. That was really hard because when you get down in that bottom core, this gets stuck and it's really hard to do one-handed. But we have it centered. So now we're at our 98 megahertz. And we want to fine-tune it observing the tuning meter. So you're going to center the meter, which I've done. They want you to set it to minus 60. Alright, so we're at minus 60. And adjust T1 upper core to minimize distortion. So again, I think this is one that's not going to need very much adjustment. I'm trying to see if I have a little better tuning tool here. Alright. And let's adjust this and see what we get. Look at that. See if it peaks out right about there. And let's drop this down until we start getting some distortion. And we want to minimize that distortion. Alright, I'm back. About there's about as far as I think we're going to get. Our meter is centered. Our distortion is pretty well centered. I think we're doing good. Okay. And that takes care of the FM section. Now we're going to look at multiplex, and I'm going to have to do some setups for that. Okay, here's what I came up with. So I'm feeding into my signal generator an external FM modulation, and if you look, I'm just coming out of my SG165 with strictly a multiplex signal. That's it. So I have my multiplex, I have my left and right on, and my pilot. I have my output set fairly high, but not too high. Turn it down a little bit. And I'm set to my 98 megahertz. I'm at negative 60 dBm. Feeding into here. I'm coupling the output of the multiplex into my scope on XY mode. And I'm taking this probe and going to test point 10 as per the directions. Now this is not the same setup they have. I don't have the same test equipment they do in the book, so I'm kind of making do with what I have. I do not have a perfect hysteresis Lissajous pattern, as you can see, but I can adjust the output here of multiplex, and you can see I can turn off each channel. And basically what we're doing is FM stereo light is on, and if you get it just balanced right in the center, these will look like that, and your stereo light will be on. If you go off of it, you lose your stereo light, and those go equal like that. They don't alternate with one another. And that's about as close as I can get it. Now, once again, this isn't a perfect setup. This is not textbook, as I do not have the I don't have the same test equipment to set this procedure up, so I kind of made do with what I have. Alright, so we got basically VR2 is just to get the pattern still, which I did. VR3 minimizes the audio frequency output level. Okay, so we adjust VR3, which is down here, and again, it's pretty much in. And again, we're just going to balance that out. And turn this down just a hair. And that's about as good as I'm going to be able to get it with my scope and with my setup. You can kind of see, if I turn it way up, you can kind of see part of the pattern there, but again, that's the best I could get. It is tracking, it is on, it is doing well, so I'm not going to complain. I think we're pretty much tuned in. Now we're going to go to the AM section, which is going to be really easy after all this. Okay, before we go to the AM, I thought I'd give a FM a little test. I'm hooked up to my antenna, and as you can see, I'm picking up way more things than I've been able to before.
That helps the net, but I'm more concerned with the
Featuring 16 all-new shows, a sharp sonogram.
And you can see the FM is real sensitive now. See that? So I am extremely pleased. So this is basically, turn this back down. This is a lot more sensitive tuner right now than that SX1050 even, which actually turned out really well itself. So I'm very impressed. This is not their top of the line, this is their middle of the line receiver. Almost makes me want to try to find a TX 9500 and with the 5-gang tuner, just to see how much better it is, because I can't imagine what that would be like considering how this one performs. Again, these little tuners are kind of an afterthought in modern audio equipment. People don't really put the design into them they used to, because, you know, everything's going MP3s and online and all that. But wow, amazing what they did. Alright, let's move on to the AM. Okay, much simpler here. For the AM, we're going to do 400 cycles of modulation, 30%, minus 30 dB, 600 kilohertz, which we've got that all set up, as you can see. And we're going to go to T2 and maximize the frequency output, which is right here, this little red one. And then we're going to adjust the antenna bar, the core in it, and then we should be able to have everything set up. Let's see what we get. So there's our signal. I bet you it's already on. Yeah, it was pretty close. Okay. But usually where you start seeing the issues is in the bar antenna. That always seems to be out. And we need a pretty heavy screwdriver for that. Let's use one of these. And right inside there, there's a little slug. And that should adjust as well. I can't turn it. I'm going to have to loosen it up off camera and then we'll try it again. Okay, I did this this in 2 steps. So the first thing I did was I adjusted T2 for peak, which you saw that on camera. Off camera then what I did was I disconnected and just loosely coupled the cable to the generator, because you really want it to pick it up through the air, sort of. So that's what we did, and then I used the bar antenna and adjusted that and basically maxed out my signal at minus 30 dBm. So now we got that part done. Now we're going to move up to 1400 kilohertz. So frequency 1.4 megahertz. All right. Okay, we're in the home stretch. Only thing left to do is I'm at 1400 kilohertz, and I'm just going to go ahead and set these 2 adjusters here on the tuning capacitor for maximum amplitude, and we should be set to go. So we're going to use this one and this one, the 2 that are not marked. This one and this one. So go in here, let's get on to our signal. Kind of tough with one hand. Okay, that was on. So far nothing has been out at all. One's pretty good too, so I'm thinking we're in good shape. So that is it. I think the only thing left to do now is put it all together and give it a test. Very simple. Alright, real quick, we're done, and cabinet turned out really nice. Put some new feet on it, as you can see. And now I'm gonna call this one a wrap. Hope you enjoyed.